everything that we do and everything that will be upcoming. So for instance, events and meetups such as this. So just some quick house rules. This meetup will be recorded, and then you can find the video recording of it later on the dev portal, which I will be showing everyone. And please hold your questions to the Q&A segment for our speakers. And just very briefly, this is the program for this evening. So a bit about GovTech. I think a lot of people are very familiar with us, but just for people new to us tonight, this is who we are basically. So there are three groups: products, services, and cyber and governance. So the products group actually is made up of over 700 developers who do centrally developed whole of government products. Services group, we are in charge of over 60% of government agencies and the CIOs and technology officers in the government Singapore government actually sit here. And cyber and governance, this is where our group makes sure that everything that we do is safe and secure. So I'm sure a lot of you are also curious about the different offering that we have. So Stack Conference, which is the largest and flagship event that we have, it's held every 2 years. Please look out for the one that's upcoming. We just held one last year. The Stack X, which is a single day conference. A lot of exciting news coming up, which I will share with you in the next slide. And Stack Meetup, which is the one that you are here, a casual sort of event for our community to get together, learn and share with each other. So once again, if you have not joined the Stack Telegram, this is a good opportunity to join us. Why is this so? It's because we are going to have the Stack X Data and AI event that's happening very soon, July. And on good authority, I have heard that everyone is very excited for the speaker. So Dr. Andrew Ng, the founder of Deep Learning AI, will be joining us. Thanks to the DSAT team here from GovTech, Jason and his team, who have worked very hard to bring all these exciting speakers. So if you join us here, please join us now. You will get notification first of when registration for the event is going to happen. So yep, I see some of you raising your phones. I'll let you have a bit of time to scan the QR code. Okay. So about the dev portal, this is where we actually share what I mentioned before, the video recording, as well as a lot of resources about products that we have. So if you join the dev portal here, you will be able to get all the video recordings from this session, as well as our past and subsequent sessions. So you might also like to scan the QR code here. This is where our data science and AI collection resides on the dev portal. So basically all the resources, all the content about what GovTech Data Science and AI Division does. So without any further ado, let me introduce Dr. Yap Kim Eng to give the opening sharing.
Thank you. Hello. Hi. Okay. I'm Kim Eng. I'm Director Data Engineering, DSAT, which stands for Data Science AI Division. Thank you so much for attending this evening. I hope you all had a chance to grab some bites, okay, either before this or at the back at the pizza just now. Okay. So tonight we have a full lineup of events for you. Okay, to be delivered by our own data engineers, our resident privacy researchers, okay, as well as collaborators from Snowflake. So the technologies covered will range from the anonymization tools that we developed for government, as well as the differential privacy tools, okay, as well as the concept of a data clean room. So get ready for a night of learning, okay, and most importantly, thank you for attending this, and please feel free to mingle among yourself, because the key objective of having a meetup, a physical one, is so that you can talk to people beside you and to get to know who is in this community together. Okay, so looking forward to achieving this concept of trust in digital government together, as well as working with the private sector in this. Thank you. Thanks. Yeah.
Okay, so I will maybe get Shari up on stage. She's our next speaker to do a quick intro on himself.
Right. Thanks, Giming, for the introduction, and welcome everyone to this segment of Introduction to Data Privacy. If there are two things that I want you to take away from my talk today is firstly, to understand the data privacy landscape as it is. And secondly, there's always a need to balance between privacy and utility. Hi, my name is Shahri, a data engineer from the Data Privacy Protection Capability Center. Sorry. So in short, it's actually the data privacy team. And the data privacy team actually has three main missions. Firstly, it is to develop the government's capabilities in data privacy protection technology solutions. Secondly, oops, to change those, or rather to take those capabilities into implementation for the whole of government. And lastly, to provide consultancy services to all the different public agencies out there in terms of, or rather in the matters of data privacy protection. Yeah. So this is the rough agenda for today. Do have a brief read through. And let's begin with the very definition of data privacy. So data privacy, as it states by NIST, it shows here that data privacy is the assurance that the confidentiality of and access to certain information about entity is protected. So you might be asking like, hey, what is data privacy for today? I think most of us can answer that, but let me just give some examples. So first of all, for some based on a study in the US, already 87% of us can be re-identified with just three of these attributes. So your zip code, gender, and date of birth. So you don't even need your name or personally identifiable information to get re-identified. And second of all, probably something that most can relate to, the rise of LLMs, your handy dandy ChatGPT. There's millions and millions of users who are onboarded to these platforms, not really understanding the concepts behind it. And unfortunately, some of them have uploaded sensitive data to these platforms. And definitely, something that unfortunately have happened to Samsung as well, there were leaked trade secrets. Now, just to add a couple more factors into that as well, there's also wealth of data that's being collected by governments and as well all of the companies today, and they accumulate large data stores. With large data stores, that actually brings in one thing, which is there will be a lot of cyber attacks. And if any of these cyber attacks were to be successful, surely data privacy will be, at risk and at stake. So there are a lot of ways that we can solve data privacy, but today we'll be looking more in the terms of the technology standpoint. So this is something that's called the privacy preserving technology. So in short, it's called PP Tech. There are a lot of PP techs out there, but I have identified a few over here. So for example, you have your homomorphic encryption, you have your secure multi-party computation, as well as trusted execution environment. So these three techniques actually has already is associated with the goal of input privacy. So what does input privacy means? It's actually you use these three techniques when you do not trust who computes the data, right? So there's also the other hand, which is these four techniques over here and a couple more that I'm not showing, which is federated learning, synthetic data generation, differential privacy, and data anonymization. So you use four of these techniques when your goal is really, already you do not trust who views the output of the data. And this is actually categorized under the output privacy. Yeah, so first of all, let me talk about input privacy. So again, input privacy means you do not trust who is computing your data. So let's have a very typical flow of how, let's say you have your local computer, and then you want to upload it to a particular server, and then you wish to do some data processing. So first of all, you have your data, and after which first protect your data by encrypting it over the networks. And the moment it reaches your server, then your data will be decrypted so that you can do data computation, right? So this is pretty normal. And really, what I mentioned earlier about input privacy is that you do not trust who is computing your data. So if you do not trust who is computing your data over here, surely this is a security and a privacy risk. So how does homomorphic encryption or rather how does homomorphic encryption is being applied to save this problem? It's actually, similarly, it starts off your data flow, you encrypt it in some transit, and then the data is never decrypted. So the computation is actually happening on your encrypted data itself. And the only time it's actually decrypted is when it goes back to the destination that it's meant to be. Yeah, so that's homomorphic encryption. So let me give you an example of federated learning. So federated learning is with the goal of output privacy. So let me just give an example over here. So let's say you have provider A, B, and C. These are your email providers. And really what these email providers want to do is to create a spam engine. So potentially using, say, models, right? ML, etc. And this is pretty normal. So for example, you see provider A, they have their own data points, they create their own models, and then they have their own spam engine. And I mean, in this way, they're still working in silos. So you have your individualized machine learning. This is pretty normal. So sometimes you just want to take it a little bit further, which is using centralized machine learning, where at this point you realize that there are multiple providers that are going to a central location, which is your central, your central shared data store. And in this shared data store, there are a lot of data points in there, which are from all the different providers that you see. And really, that's where they try to, potentially with more data points, you can potentially build a better model collaboratively. But in this case, there's a privacy concern over here because it's in a central location. So that's where federated learning comes into play, where you really try to put in both of those two concepts together. So firstly, you have your different providers building their local models, and using their local models, they try to build a global model. And the most important part here is that the data never leaves their original data points, or rather the data source. So that's output privacy. That's how we can keep privacy in place. Right, so I have just introduced two PP tech. So this is one of the most matured PP tech out there, which is statistical disclosure controls. Maybe something that rings more bell is when I try to break it down a little bit further, which is data anonymization. So data anonymization, pretty common out there already. So, but let me just give a primer about it. So for example, you have your raw data, your column name and data values as follows. And for data anonymization, what you actually have to do is that there's a certain process that you must abide to, right? And in this process, there's anonymization techniques. There are multiple of anonymization techniques out there already, but let me just give you some examples in this particular site. So in this case, James Bond, if you were to do suppression, for example, the anonymized data, or rather the data values that comes out of it is a dash. And if you were to do pseudonymization, or most commonly known as hashing, right? So what you do is that from the data values of A, B, you get a tokenized form or a one-way function to what you see over there, the data values over there. Then maybe something that's easier to explain, generalization. Basically your date of birth from the 5th of December 1950, you strip away the day and the month, and then you're left with 1950. That way you preserve a little bit of the utility of the data. And something most are probably very familiar with, which is masking, right? So you remove the first 5 characters, or rather you mask the first 5 characters of your NRIC. Now, the most important thing that we need to take note of in this slide is really the matter of anonymity versus utility. Just imagine that you have to do analysis on this particular data set. Then definitely the values at the top are not as important as the values at the bottom, right? Yeah. And so that's really more of the trade-off that I was talking about, right? So there's always a balance between anonymity and utility. Then next, we have something called the k-anonymity, which is also part of statistical disclosure controls. I think k-anonymity is always best explained with a particular scenario. So let's have a go here. Let's say you have an annual employee survey, and it's probably hosted in a company. And in this company, there are 18 males as well as 2 females. And usually after you have done the data surveys, already the surveys, what will happen is that you have this particular data generated. So your name, age, gender, as well as your employer rating. And since it's term anonymous, so the data itself for the name itself, so it's gone, right? So you can no longer be re-identified. Or can we, right? So that's really the question. If I tell you like that, then definitely you can be re-identified lah. So what happens next is that for typical surveys like this, you always have something that outputs out of it, right? And it becomes a bar chart or any sort of charts, in fact, that is actually seen by a certain somebody. So maybe in this case, the categorization here is that you have the average employer rating by gender. It shows that, oh, the male is quite high, there's a high rating in there, whereas the female is quite low. And sometimes what makes it worse is that you can even drill down And once you drill down, you realize that there's only one female that is less than 35 years old and one female that is above 35 years old. If you were to relate to the context above, you realize that you can actually be re-identified. Maybe from our point of view, we don't really know who is that person over there by looking at the graph chart, but usually who's viewing this data is the boss of the department. Won't he already know which one of his employees is a female and less than 35 years old and that above of 35 years old? So just to dig in a little bit deeper into k-anonymity concept, over here, k-anonymity is a property of a particular data set. And really what you just have to remember from this slide over here, when the k value is lower, such as k value of 1, the data is usually associated with it being less risky, or rather more risky. And the higher you go up the scale, usually it's being associated with being less risky. So let's say you have this particular data set that you see here. You have name, age, gender, and rating. So what happens is that you might want to know, how do I get the k-anonymity of my particular data set, right? And what you can start off with is to select the data set identity revealing characteristics. So identity revealing characteristics are pretty contextual. And in this case, I've chosen age and gender, but you might be asking, why am I not choosing name? Well, that's because name is identity revealed, whereas age and gender is identity revealing in certain contexts. So it's pretty much a very contextualized base where you can choose your particular identity. And from there are a few standards out there already, such as HIPAA standards that you can potentially look at, where they already have some established rules for you to have a look at. Yeah. And after actually selecting your identity revealing characteristics, the next few steps are actually quite simple. You just have to find for all the different sets of combinations for the selected columns, basically just find for the unique groups. And once you have the unique groups identified, you just count for each, or rather the number of rows inside each of the group, right? So in this case, there's 2211. And the last one, the easiest one of all, is to find for the minimum row count of the group. So this way, you can see that the minimum row count for, say, 17M and 18M is both 1. Therefore, your data set itself is k-anonymity of 1. Now, I mentioned earlier on in the scale that if your data is k-anonymity of 1, that means it's more risky. So how can I ensure, or rather, how can I increase this, or rather, lessen this risk? Well, what you can do firstly is to remove those that have the minimum group row count. Then you realize that the current group minimum row count is 2. Therefore, your data set k-anonymity is 2. But you realize that by removing these two particular rows, you also lose 33% of the data set. And if you were to do data analysis, that is a no-no, right? So what else can we do? We can actually suppress the combinations instead, where row 5 and row 6 was 17 and 18 respectively. Now we change it to a dash. And since it's a dash and it becomes a group of dash and m, it's also respecting the k-anonymous of 2. But I'm still losing some cells value over here. So what can I do? I can actually generalize the numbers over here. So now 17 to 18, definitely the values over here makes more sense to be used for further analysis. So that's k-anonymity. And really just to re-highlight that this just helps with identifying the re-identification risk for your data sets. And over here is really just to bring every of the concepts together that I've just mentioned, which is in the whole of government, there's something called the anonymization guidelines. So for anonymization guidelines, it follows a very similar concept where you see from personal data, it goes to data anonymization. And in data anonymization, what you have to do is standardize anonymization treatment. So what does that mean? Earlier I mentioned that there are a lot of different techniques. So in this case, maybe you have a data set which is NRIC columns. So for NRIC, what you must do is to transform the data using the anonymization technique of, say, masking. If you have zip code, maybe you have to apply the transformation of pseudonymization. So it depends, and there are a lot of rules like that, which I'm not showing, but you can just imagine how many rules that we can have. And then after actually applying the standardized anonymization treatment or data anonymization, what you can do is to, is to do the key anonymity. And I think I've just mentioned that in quite in depth. And after reviewing your risk with key anonymity, you can get the anonymized data. But I hope I haven't lost any of you, but if you're lost, it's okay. Uh, really the intent of what I'm showing you here can be extracted out to a simple platform that we have built, and that's called Encrypt, or the long form is Enabling Central Privacy Preserving Toolkit. Yeah. And really what Encrypt does is as follows. So it's actually a self-service web application that really helps you with two things, which is data anonymization, as well as review re-identification risks. So you can see that if you remember from the previous slides about the whole of government anonymization guidelines, you can see that the Encrypt logo over there can actually be interchangeable with the whole of government anonymization guidelines. Yeah, so that's really the intent of Encrypt at this point. And at this, we have just launched last month with over 70 different agencies that are already onboarded with us. Yeah. So I also do not have a lot of time left, but I just want to show you a product demo, a single flow of how Encrypt works. So hopefully you can get a glimpse of how Encrypt works. Do enjoy. Right. I hope you managed to catch a glimpse of how Encrypt works through that very short video. And really, what I'm showing you in this particular slide is or rather, some of the use cases that we have in Encrypt today. So, for example, in use case one, some of the agencies are applying pseudonymization technique uh, before actually doing NLP analysis, so that they protect the residents' privacy. And then, something that I've mentioned earlier on, some of the agencies are also doing whole of government anonymization guidelines for just before doing public release. And lastly, there's also healthcare sector agencies which are using it to de-identify patient data before actually ingesting it to the particular data sharing platform. And just a shout out to all of the public sector officers in the crowd today. Feel free to register at encrypt.gov.sg. So this is a short segment about data privacy and data engineering. So the data privacy team that I'm from is actually part of the bigger and broader data engineering team. And there are a couple of systems that already exist in data engineering. So what I'm going to be showing you in the next few slides is how the systems can integrate with data privacy in the future. Yeah. So we have just seen Encrypt, but let's get to know its bigger brother or bigger sister, Entrust, right? What Entrust really do is it helps from agency A, also any public sector agencies, to collaborate with a certain private companies for an intended research result. And when we do this, definitely data sharing in place. And when there's data sharing, definitely data privacy is you require data privacy. And next one, we have something called DIAB, which is data infrastructure in a box. So when you see, you can just refer down to the infographic below. So agency that doesn't have any data infrastructure or plan to create a new data infrastructure can use DIAB to quickly and securely spin up a new data infrastructure. And from there, you see that in the new data infrastructure, you have multiple layers such as data ingestion, transformation, and exploitation. And wouldn't it be interesting that in the future, we have data privacy as a layer as well? That would definitely change the ballgame of how we build data infrastructures today. Then one of the other ones that we have is analytics.gov, which is AG. So just imagine that in multiple different public agencies, they can connect to AG. So from the different data sources such as data warehouse, files, and databases, they can use AG as an exploitation environment. And in that particular exploitation environment, you can collaborate very effectively. And they are also supporting something called ML Ops, which is machine learning operations. And when we are talking about ML Ops or ML, as well as collaborative environment, wouldn't it be interesting to have federated learning in there as well, since that's where privacy is ensured? And lastly, we have DE-CATS, or what we call the Data Engineering Capability and Adoption Team. DE-CATS is a team of humans, not cats, that are really trying to provide recommendations to agencies to uplift their data engineering capabilities from zero to hero, or from one level to the other. And a byproduct of it is actually called the Data Engineering Initiatives Playbook, where you really have an accumulation of best practices of data engineering, firstly, and something that we can look forward to is a segment of data privacy in the future. So just one last slide from me. What's next for us, especially the Encrypt team, is that we want to enhance the statistical disclosure controls that we have today by providing more modularity, such as APIs, or integrate with all the whole of government platforms. And with something that we don't really have today, which is free text anonymization, where today we provide only tabular data sets, or rather tabular transformations. Then something that's quite interesting as well is the whole of government synthetic data generation. So this really is by providing a very nice UI, hopefully. And what it does is really from raw data, you can create synthetic data. So synthetic data is basically like a fake data, but it has something that's important, which is statistical fidelity, so that your models that you build can still produce the same results, although it looks and feels the same. Yeah, protecting some privacy in there. And lastly, something called the whole of government differential privacy, where I didn't really mention about differential privacy just yet. It's actually one of the PP tags that's also most matured, but I'll leave that topic to my colleague who's going to be talking way more about it. Let's welcome Anshu, who's going to be talking about.
Okay, let's try to get you excited about differential privacy. Before that, I have a question for you guys. Okay, most of you are frequent Google Maps user. Okay, even today you must have used Google Maps to reach here, right? But my question to you is, do you know that you probably contribute to differentially private analysis of traffic for the public good? Good, nobody knows. I can teach you today. I'll try. And so the point is, I want you to reflect on the how of the statement by the end of this talk. So for now, just consider it as your homework. So today, we will be covering how differential privacy can overcome the limitations of traditional anonymization techniques, what is differential privacy and its privacy guarantee, with a specific focus on this key privacy parameter epsilon. And I'll also walk through its key properties, applications, and real-world use cases. And then I'll touch on our contribution towards this emerging field. Okay, so before I get started with differential privacy, let's take a step back and try to understand why was it even invented. So there are some known privacy debacles of traditional anonymization techniques. These techniques include ad hoc methods that Shari just now covered, like k-anonymity, generalization, and so on. And in order to apply these techniques, you have to make certain assumptions about an attacker's background knowledge, computational powers that they can potentially exploit in order to re-identify individuals in an anonymized data set. And even after all those assumptions, you get privacy guarantee only in empirical or heuristical sense, right? So the challenge is, how do we go about quantifying this privacy guarantee? And then there are these innocuous looking aggregate releases that can also potentially lead to reconstruction of the entire data set, or even singling out of the individuals that can eventually lead to re-identification of the individuals. Now, the point is that too many and too accurate statistics can be blatantly non-private. And the challenge is, how do we go about quantifying the privacy leakage that occurs on releasing multiple statistics from a data sets about an individuals? And then, even if we want to release noisy statistics, how to estimate the amount of noise that needs to be injected to get a balance between privacy and accuracy. And it turns out that differential privacy is exactly what can be helpful here. It can help you to quantify and provide provable privacy guarantee. You don't have to make any assumptions about an adversary's auxiliary information or computational powers. So you will see that differential privacy definition does not really care about all these assumptions. And then you can quantify the accumulated privacy loss that occurs on releasing multiple statistics from a data set. All right, let's get started with differential privacy and try to understand its privacy guarantee with the help of a scenario. Okay, assume Ministry of Health is conducting a survey on smokers and their smoking habits. And this survey can be used for research purposes that can provide societal benefits. Okay, by now it is clear that Shari is such a privacy conscious person. So he's concerned that the survey questions that are asking for his personal information might someday be leaked, and that might cause him some sort of harm. Maybe reputational harm, monetary harm, some sort of harm. Now, differential privacy can be useful to address Shari's concerns in this scenario. Okay, so intuitively speaking, any analysis protects the privacy of an individual if the output of the analysis does not leak information about any specific individual in a data set. And if Shari's information is removed from the analysis, then his privacy is protected in a way that the output of the analysis does not depend on his specific information. And differential privacy aims to protect Shari's privacy in the above scenario, that is with this record included, in a way that mimics the privacy protection that he is afforded in his opt-out scenario. Meaning, the output of the analysis with and without his information will nearly be the same. And to get this similarity, differential privacy adds some calculated amount of noise to the statistics before they are released. So we'll talk about what is this calculated amount of noise, but let's focus on the idea that the output of the analysis will not be conditioned on Shari's information. And this gives Shari this plausible deniability, and he can claim that, okay, I was never a part of this survey data. And crucially, this privacy guarantee is not just with respect to Shari, but also with respect to each and every individual who might participate in the survey data. All right, let's also talk about what differential privacy does not protect. Assume the output of the analysis is public, which states that smoking causes cancer. And Alan, who knows Shari, concludes that Shari is a smoker and he has a heightened risk of developing cancer. Now you must be wondering that Shari's privacy is breached. Well, no. There is no guarantee that no information about Shari can be leaked or revealed. Shari always has this plausible deniability. He can claim that, oh, I was never a part of this data set. And this guarantees that no information specific to Shari can be revealed. The point is that differential privacy allows you to learn about the general trends, population, but not about individuals' private information. So if your use case involves learning about individuals, outliers, or even small groups of people, then differential privacy is not the right technique. Okay, so by now you must have developed some intuition around differential privacy, which essentially states that the output of the analysis will not be sensitive to any individual's data. Okay, so now you must be wondering, how does it actually work? And for that, I'll introduce a little maths. The idea is to make you comfortable with this notion of key privacy parameter epsilon, such that it can help you to make more thoughtful choices when it comes to setting its value. Consider two data sets that differ in one person's record. This can be addition or removal of a record. These are called neighboring data sets. And on applying a mechanism on these data sets, okay, a mechanism is simply a lingo for an algorithm or a function in differential privacy. And in simple terms, this function just adds random noise to a query output. And a query can be any interaction with a data set, like sum, mean, count, and so on. All right? So we'll talk about what is this random noise as well, but let's focus on the output of the mechanism, that is randomized values. So the probabilities of the outcome of the mechanism will essentially be the same, and this depends on so it will be same for the neighboring data sets, and the similarity of the probabilities depend on this privacy parameter epsilon. The smaller the value of the epsilon, the more similar the probabilities will be. The distributions will be closer. And because of this increase in the similarity in the probabilities, any attacker's uncertainty of any individual's contribution in the data set increases. And that is why the individuals get this plausible deniability. So basically, this illustration is capturing this differential privacy definition, this equation basically. So anytime you come across this equation, just remember this illustration. I believe it might make your life a lot more easier. But yes, to sum up, this equation is basically conveying that the probabilities of the output of the mechanism on the two data sets that differ in one person's record will be bounded by e to the power of epsilon. Or to another way to put is, an attacker's information gain will be bounded by e to the power of epsilon. Okay, so to summarize and to put it in simple terms, epsilon is like a tuning knob to handle your privacy utility trade-off. The smaller the value, the more privacy you get, but it degrades accuracy. This is because of the increase in the noise scale. Essentially, you are smoothing over the possible outcomes in order to get more privacy. All right, what about the noise? The noise comes from the distributions that satisfy differential privacy definition. And one of those distributions is Laplace distribution. Okay, so it has some nice characteristics which makes it satisfy differential privacy definition. But let's now focus on Laplace mechanism. So let's revisit what is a mechanism. A mechanism adds random noise to a query output, right? And Laplace mechanism adds random noise from the Laplace distribution. And the noise scale, or the spread of this distribution, is computed as sensitivity upon epsilon. Now, sensitivity is another very important concept in differential privacy. So, sensitivity of a query measures the maximum possible change in a query's output when a record is added or removed. Okay, let's take an example. If I have to compute the sensitivity of a count query, I'll ask you this question so that I'll make sure nobody's sleeping here. If I add or remove a record in a data set, then the max the count query can change is by how much? Yeah, it's 1. Okay, so the sensitivity of the count query will be 1, because if you add or remove a record from the data set, then the max the count query can change is by 1, right? And for other queries like sum and mean, it can be more complicated. But to keep it simple for this session, let's focus on count query. Important point is that sensitivity of a query helps to determine the amount of noise that you need to inject to hide each and every individual's contribution in a data set. That's the main point. All right, let's put everything together in the story example and try to compute a count of survey participants with differential privacy using Laplace mechanism. So as you can see from this diagram, Shairi has already participated in the survey. He's convinced with the differential privacy guarantee. So if my true count is 1,000, that is the number of survey participants is 1,000. And as we just discussed, that the sensitivity of a count query will be 1. Then the noise scale will be computed as 1 upon epsilon. And epsilon you have to set based on your privacy requirements. And on running Laplace mechanism, so Laplace mechanism, it will add a random noise from the Laplace distribution to the true count, right? Let's see what happens when we run Laplace mechanism multiple times, maybe. Okay, yeah, it loaded. So on running the Laplace mechanism, you can see it outputs randomized values. The value will be close to your true count, and the accuracy will depend on your epsilon value. As you can see from this graph, if the true count is 1000, then the error is dependent on the epsilon value. The smaller value of epsilon is giving higher error because of the higher noise scale as compared to the higher values of epsilon. Another very important point to reiterate is that if you randomly add or remove a record from the data set, still the output will be nearly be the close. All right, let me now just walk through the key properties of differential privacy. So by now you know that we can get provable privacy guarantee with this epsilon privacy parameter. And we also saw that how you can guarantee privacy guarantee to individuals in the data set. But you can also provide privacy guarantees to group. So this group can be maybe a group of family members, or an individual might be contributing to multiple rows in a data set. Another very powerful and important property of differential privacy is composition. So one might want to run multiple queries on a data set. And with each query, you leak information about the data set, about individuals. And with differential privacy, you can quantify the accumulated privacy loss by adding up the epsilons that you spend for each query. In fact, you can set a set epsilon value, this is called as privacy budget, and split it across the different queries that you want to run on your data. This is similar to you go for shopping with a fixed budget and you want to spend more on certain items. Similarly, you might want to spend higher epsilon values for the queries that you might deem require higher accuracy. Okay, this is the last property and very handy one. It is post-processing. It states that you can do further computations on your differentially private releases, and until and unless you don't go back and touch the original data set, the privacy guarantee will still hold. So this post-processing or this function can include maybe improving the noise signals in your differentially private releases, like converting negative values to positive values. Or it can also include some sort of privacy attacks, like linkage attacks or some sort of reverse engineering attack that an attacker might try to use to break the privacy guarantees. But post-processing properties states that the attacker will be unsuccessful. The privacy guarantee will still hold. And more advanced usage can be in the domain of machine learning and synthetic data generation. All right, let's talk about applications of differential privacy. So today I just covered how you can use differential privacy to release protected aggregates, right? But you can also use differential privacy to generate differentially private synthetic data. It will provide you added level of privacy protection. You can get provable privacy guarantees. And then you can also train your machine learning models using differential privacy. It can help you prevent memorization of sensitive information in the training data set. In fact, even for the large language models, it has been suggested as one of the solutions in order to prevent model leaking sensitive informations from the training data set. All right, let's walk through some of the real-world use cases of differential privacy. So US Census Bureau, they use differential privacy in order to release certain statistics about the earning and employment outcomes of college graduates. And this provided privacy guarantees to individuals in the data set. So Apple, in order to calculate which emojis are most popular among users, they use differential privacy. So they basically injected the noise in the data that was coming from the remote devices. So right now we just talked about how you can inject the noise to the release aggregates, but you can also inject the noise to the data points. And this is called local differential privacy. Next, this is one of my best use cases that I believe. This is because it shows how differential privacy has impacted a vulnerable community. So Microsoft collaborated with the International Organization for Migration in order to publish differentially private synthetic data. That was about perpetrators and victims. And with that, they provided privacy guarantees to the victims in the original data set. So Google also used differential privacy in order to train their next word prediction deep learning model. And with that, they were able to prevent model from memorizing the sensitive information about individuals in the data set. All right. So let's also talk about the privacy parameter epsilon. As you could see from these use cases, that the epsilon value was ranging from small to high, right? And it is generally recommended, especially from people from academic settings, that your epsilon value should be less than 1 or nearly equal to 1. But as some of the experts have rightly quoted, that setting your epsilon parameter or any privacy parameter that is linked with differential privacy, it depends on context and use cases. Because in certain use cases, you might not require so conservative privacy. And most importantly, setting a privacy parameter is just a small part of your data protection. You might have other layers of data protection as well, like security. So in short, setting differential privacy parameters depend on your context and use case. All right, that was about differential privacy. I hope so. I was able to get you somewhat excited or get started with differential privacy. But now is my favorite part where I will be talking about our contribution towards this emerging field and how we intend to streamline the adoption of differential privacy in collaboration with industry and academic experts in the field. So addressing one of the major gaps in differential privacy, we have researched and evaluated the major Python tools on their features, scalability, and utility on dataset of up to 1 billion data points. We have also provided guidance for practitioners in adoption of a tool. So this is just a summarized version of our analysis. And we have also provided a deeper in-depth analysis in our 4-part medium series that covers differential privacy right from theory to practical implementation. So our motive is not just to help non-experts to get started with differential privacy, but also help the tool creators to learn from each other and how to address the gaps in their tool. And we could clearly see one of the tool creator, that is Tumul's Lab, how they benefit from our research. And we have also open sourced some of our codes that also include some of the guided notebooks that can help you get started with differential privacy. And all the medium series that I just talked about is also put together in this white paper that we will be releasing soon. And lastly, the most exciting part is that we are working towards developing a web interface that can help non-experts apply differential privacy with ease. And to develop this tool, it is important that it is credible and robust. And that is why we have collaborated with industrial and academic experts. That's it. Thank you.
Session on data clean rooms. Jie Hong, please.
Yeah. Good evening, everyone. So I got to admit, I'm not a privacy implementation expert, but I got to say, I'm the paranoid little guy over there that will use Google Map in incognito mode. I'm just worried about everything, right? So, every little mobile app that's prompting for permissions like why would this app needs access to my local network and all my photos in my mobile phone? Like, so I'm that person, right? So if I'm putting on my cyber hat, I used to educate people around not clicking on, unknown links. But nowadays, everyone, when we flash a QR code on the screen, they like automatically click. So my name is Jie Hong. I'm from Snowflake. Oops. I work for Snowflake as a public listed company. This is standard procedures. We would have safe harbor and disclaimers around forward-looking statements. So I will call it out if I make any of them. So I guess for today, I really want to share how we would securely bring data to the cloud. That's one. Second of all, how do we share and collaborate on data? And lastly, what are some of the real world use cases in implementing data clean rooms? And I think some of the earlier talk from both Sharif and Anshu makes a lot of sense. So I would try to reference, some of the parts that they have been covered earlier. So I guess everyone will be thinking about, if I'm going to bring data to the cloud, how should I do that? What are the platforms that I'll be thinking about? And more importantly, it has to be a platform that supports all my workloads, for example. It has to be easy to use, but I think more importantly, it has to be secure, compliant, check all the right boxes, and easy to use. And second of all, we are seeing a growing trend. Again, when we want to share data and collaborate among um, public agencies and extending public and private collaboration as well. How do we accelerate that collaboration, but yet, keeping things secure and governed at the same time? But more importantly, when we see the rise of all the LLM models that we have seen, I think there was an early example around that as well. So a lot of times we are shipping our data to a provider that's distributing, their proprietary content through API. So we're kind of shipping data there, and we kind of lose control sometimes. So how do we take back that control and also bring data and data services, especially from third party, to your environment, to your data instead? So one of the ways that we look at data sharing, so there are a lot of definitions around data sharing. So I think very commonly, someone will say, I have published a dashboard, and yes, I have shared data. But sometimes we will want to bring more utility to that as well. So we also want a platform that allow us to easily share data. But more importantly, it's not just about data sharing. There could be certain scenarios where I don't want to share the entire data set. I could be sharing certain functions, and that functions will be useful to you to enrich your data set as you're running your own analysis, right? So that's one way of looking at it. And more importantly, when there are forms of data collaboration, what is always very, very difficult is around setting up data pipelines to move data back and forth. And more importantly is, if we have slow changing dimensions in a data collaboration manner, we will have to have some form of CDC as well. So how do we set everything up in an easy manner? So that's something that we have to think about. And what is interesting is we could and we can share data today with just a few clicks of a button or a couple of lines of SQL code. And you can actually share data easily. And that could be ready to be created live by the data consumer. But there are always situations where, what if I'm sharing with another consumer? So I'm a data provider. I would like to monetize my data. I would like to share my data. But my consumer is on other cloud platforms, other hyperscalers, or it could be collaboration with overseas as well. So in those occasions, that's where maybe, I have to find my way to move the data out from my environment, bring it to another cloud, and how do I do all of that easily as well? So we will need then to have an easy platform to do that for you. But more importantly, there's always this debate about, if I'm sharing data, especially cross cloud, who is responsible for the egress costs? The data provider or the data consumer? So it's a very difficult thing to balance. So I guess it's around, how do we make it easy for you so that we could then co-locate the data to where the data is to be consumed, so that as a data provider, I could easily budget, my egress costs, balance between how data is fresh to the consumer versus the egress cost. Okay, so something to think about. So if I want the data to be real time, updated to the very last minute, obviously there will be high cost in terms of replicating the data. But if I'm budgeting it to a point where maybe up to 5 minutes, an hour, a day, that's sufficient, then that will bring down, the egress cost. Of course, from the consumer point of view is I would have a certain demand, and if I'm willing to pay for it, why not? But at least I'm not dealing with the egress cost of providing that sharing to that consumer. So I think Sharif's presentation earlier talks about the different PP tech controls and how it's being applied, whether it's from input privacy or output privacy. So I think a lot of data platforms probably come in a way that we are securing it from a input perspective, meaning to say, if I'm making data sharing so easily, so I just mentioned, right, it needs a couple of clicks to share data. 3 lines of SQL is all it takes to share data. So if I'm again putting back my cyber hat, are you telling me is that so easy? So today, when we collaborate on a presentation slide, I just click share, I put in your email address, and you have access. Sounds good from a collaborator perspective, sounds bad from a security perspective, right? So maybe I lose control. So those are things that we probably have to think about, and how do we put those things in place so that when data collaboration is required, how can we do that securely? So that kind of gave rise to a data clean room. So as part of my talk today, I was also doing some research. So I was reading through the PDPA advisory guidelines around handling personal data. So I was trying to see, what are some of the provisions that we could look at in terms of sharing data between organizations. So it's quite interesting. So I found a very good example. So there's a certain exception where, from a business improvement exception perspective, different entities under the same group of companies can actually share your personal data without consent. So do you know that, or do you not know that? So this is a very interesting provision, right? So that's where, okay, so are you telling me that two organizations can come together, ideally under the same group of company, that could share data without my consent? But obviously, we will not be thinking that, okay, this company is just going to share my customer database, my membership database, loyalty programs, just like that, right? So I think that's kind of violating the law in that sense. So then what it needs is for a way for two organizations to collaborate, to have a safe place, a clean room to collaborate and share data. But why would they want to do that? Because there are certain use cases around collaborating loyalty programs, marketing campaigns in that sense, right? Not in terms of what Anshu is sharing from research and statistical release, but rather in terms of collaborating in addressing business needs. So from a data clean room perspective, this is probably how it looks like. So going into a bit of the details. So how can you see that happening in this environment? So I'll give a very simple example. There will be two parties in this collaboration. So I have a data provider. You can think of them as a publisher as well. So I think for those who are in the marketing space, you're probably familiar with some of this lingo. So a publisher is someone who would have their first party data, their membership, and content, and probably they would want to either monetize their membership data, monetize the data, or perhaps to sell advertising slots, right? So they are on the sell side. So party two is the data consumer, but you can see them as a retail CPG or some of the services, goods and services companies that you interact with. So that's where either they want to buy advertising slots, they want to advertise their goods and services, so they are coming more from the buy side. So everyone have seen the rise of third-party cookies, or rather the removal of that. And there's a lot of browsers clamping down, and of course Apple taking the lead in terms of privacy has kind of given the control back to the consumers in allowing what are the data that can be collected by all these mobile providers and app providers as well, right? So that's where with that remove of that third-party data, third-party cookies and all those data, how would then two parties collaborate when it's needed? So that's where everyone would have to bring their own first-party data. So I was having a conversation earlier, I think with Alan and Ian. So we were talking about, even going to Yakun today, there's also a mobile app to collect loyalty points. Like, oh, come on, I'm buying a $2 coffee. Okay, it's getting more expensive, but yeah, getting coffee, I have a loyalty program, I can collect points to offset my next coffee purchase. So, but if you think about it, why are they doing that, right? So obviously everyone wants to collect their own first-party data. So with first-party data, obviously, if I want to have a collaborative way of launching new programs, campaigns, goods and services, and everybody is talking about personalization services as well. But how do we better profile our customers and consumers? So we need to find a way to intersect this two customers' first-party data in a safe and secure manner. Again, without reviewing each other's customers and content. So what we can do here is, first of all, we have to define and maybe come into agreement. I think this is usually the hardest part, is to agree upon what are the agreed upon analysis that we can do together. What are the audience segmentation that we would like to have? How do we find the overlaps? And then agree upon what are the keys that we can join. And with that, we will be able to segmentize our customers and then define a marketing campaign to go up to the consumers. So that's where we'll create a template. So this template will contain something like this, where I define a query template that can only be used if the conditions are met. So what are the conditions? For example, if we decide to collaborate together, maybe we would join a goods and services company, with I don't know, a news media company, membership data based on email addresses. So we all sign up for most of the services with either email addresses or mobile number, right? So either one of them. So it's like no choice, I have to give up. Right? Incognito mode doesn't work all the time. So I have to give that up. So that's where we will join two tables using that. But again, we can't review that, right? So I'll come to that very soon. And second of all, I think when we hear how differentiation privacy controls can be implemented, obviously I'm just putting a very, very simple example. I think going back to some of the annual survey, like we just cut off to a certain point where if this overlap is returning less than, I don't know, 100 members or 50 members, then that is something that's too low and we will not return that. Of course, we could then also introduce other controls. If we are adding noise, then it's just about balancing again the utility and the privacy of the data. So we will join based on, say, an attribute that we agree upon, and then what other information do we need from the other party? So I'm a goods and services company. I sell shoes, but I would like to target, maybe a gym operator, so that maybe I could have a campaign together to sell more shoes in your gym outlet. But what shoes should I be selling, right? Track shoes, CrossFit, marathon runners. So how do we figure that out? So that's where we will probably also agree upon some of the attributes that I would like to enrich my data so that we can find a good segment to target. All right? So those will be the available values or attributes that we can use as part of our joint analysis. So now I have party two, which is the consumer and analyst, who would like to then start this audience overlap or market segmentation discovery. So what they'll do is, obviously they would have to generate a request. So this request will combine the approved, agreed upon queries and the attributes that's allowed with the controls in place to limit, too little values. Build a request table, and this request table will be processed by the provider. Okay, so this request will be validated by the provider. So that's step one, generate a request, get it validated. So obviously,
party one, which is the data provider, would then have to validate that this is an approved request. So you are requesting for this set of data based on your query. So the query has not been executing yet. We're just approving on the query requirements. And last but not the least, when it matches against the template and the available attributes and values is approved, and then we will store that as another table of approved requests. So to put everything together, what happens is that party 2 will then share this request table to party 1. Party 1 will also share their schema in terms of the templates, the query templates that's allowed, the available values, and the request status. So once everything is clear, party 1 will share their first party data to party B. So party 1 will share their customer database, membership database, rewards program, loyalty programs, whatever that you can think of to party 2. Remember I said it just takes 3 or 4 clicks to do that? That sounds really scary. So we would have something called a role access policy. So this diagram is not created by me. So when I first see it, it's like, why do you put a firewall there? There should be no firewalls in the cloud. That's my philosophy, right? So we can talk about it after this. So the role access policy is essentially what they term as a data firewall. So basically it's preventing any non-essential queries to be executed, so that we would only apply what's being approved into this policy, so that party 2, when they query party 1's data, joining with their own data, or their join key email address, whatever overlap that you have seen is something that we would have a joint customer together. We will not be able to query something outside of party 1's customer and something that we do not have. So in short, if we put this together, so it seems like I would have this central box defined as what we call a data clean room that allows two parties on either end with their first party data to collaborate securely and safely. So you may ask, is this implemented in real life? So we do have some examples. CPG organizations and publishers, the exact use case that I've mentioned, collaborating on finding matching data sets so that they can run a campaign. But more importantly, in terms of marketing, is we always want to measure and attribute whether is it useful. So that's where the second example is matching that against the point of sale systems. Now, if you have used Shopee Pay, Grab Pay, I'm a fan of KrisFlyer Pay as well. So now you know why they are doing all this. So these are some other examples. So essentially, data collaboration for marketing has been used widely in terms of helping organizations to plan their marketing campaigns, enrich their data so that they could then activate the necessary match audience. And last but not the least, when we run a marketing campaign, we want to measure the effectiveness, and that's how we process the last point. And with that, I just want to share that you can actually build this today. So we have actually a quick tutorial guide on that, and the code is also uploaded as part of the guide. And it's a very complex bunch of code. So what we have done is also simplified it by launching it, creating a Streamlit app to help generate some of these codes for you. Thank you very much. I'll hand back to Joyce.
Thank you so much, Xie Hong, for the great sharing. So I hope everyone is actually ready to ask our speakers all of your questions. So may I invite the three speakers as
or rather use different models, and it requires very different timings as well. So I think really to answer your question, depending on how we put out the UI, so if in Encrypt's flow, where it's still quite a transactional based data where we expect the users to get it very quickly, then definitely we need to provide a model that's quite fast, maybe a statistical model. But maybe if it's something that it's meant for long-term training, then definitely the UI may be more asynchronous. And then we think about how we can bring the users back after they have trained their data. Yeah. Hopefully that answers.
Yeah, definitely.
Maybe just to quickly add on. Hi everyone, I'm Alan. I'm the product manager for Encrypt, by the way. So just want to add on 2 points to Shari, whatever Shari just said, right? I think, first of all, I think privacy preserving technologies, we see them as a way to unlock the data that would otherwise have not been available due to either policy or regulatory requirements. So if you're talking about training machine learning models on data, a lot of times this data may not have been available for you for the data analyst to use without these technologies to begin with. And so definitely it's a trade-off between privacy utility and of course adopting some of these technologies come with varying computational costs. Uh, I think that's something that the field is improving. And that brings me to my second point, which is that over time we see it's quite a nascent and emerging space, and it's quickly developing. So I think in the past, people ruled out techniques like homomorphic encryption almost completely because the computational cost was so high. But I think we've seen rapid advances over the years, both in terms of how the algos are being run and optimizing what for specific fields to encrypt rather than just doing it for the whole data set. So I think it's a promising area. It's developing. Definitely comes with certain costs, but I think yeah, it's a net positive as a whole. Yeah.
Hi. I have two questions actually for mostly for the GovTech team. Okay, so the first question is in terms of Encrypt, what is the open source license? I assume it's open source. Is there an open source licensing model, and what kind of open source licensing model do you guys have? And number two, how does this work with PDPC, especially for us commercials, and also Snowflake? They also mentioned PDPC. How does it align? Because I don't think the anonymization is the same. Or the,
Yeah, maybe I'll take that question. Encrypt, actually, this is the first time we are presenting it to such a wide audience, yet alone a private sector audience. It's actually a very new product that we only launched last month. And sorry to disappoint you, but today it's currently only available to whole of government users. What you see, the web app is what government users can access. We are exploring making some of these technologies available open source, precisely because the way we develop the anonymization techniques are very closely aligned both with our government guidelines as well as with PDPC standards. So I think in general, we are exploring this idea of data anonymization and data privacy as some kind of digital utility that not just the government, but also the private sector can uh, benefit from. Yeah. So just we'll keep you updated on that. Yeah.
Thank you for the presentation. We have talked a lot about privacy utility trade-offs today, and I was kind of wondering what conversations went on internally when you were developing the products, be it Encrypt or the differential privacy one, in terms of like what is the acceptable level of privacy and utility. Maybe just within government, like what does it look like? I don't think we talked about it specifically, but yeah, thank you.
Yeah, that's a great question. And the good news is that Singapore is not alone in that area. Privacy is a big deal, in many countries. China, Europe especially has their PDPR. So there are a lot of international best practices to learn from. The other thing is that but it's also a field that we find that users, especially public users, or even the individual citizens are slowly coming around to that their privacy matters. I think back in the good old days of the dot-com boom and all that, people didn't really care about their data when they signed up to Facebook and just click share on everything. I think we're also seeing social sentiment shift a lot, right? But when it comes to our users and adopting some of these technologies, we're really starting, I think, at ground zero, and that's why we are tackling data anonymization first. And for that, I think as the public sector, we tend to err on the side of caution. We tend to value data security and privacy a lot more than utility. But we also have a lot of data sharing initiatives within the public sector to mitigate against some of that risk. So I think these anonymization standards that we saw were only very recently rolled out. I think we started from quite a high base at the start, but the intent is to use Encrypt to get user feedback, to slowly iterate and improve the standards over time, to kind of better calibrate that balance between privacy and utility. The second point is that I think based on our interactions with users, and I think some of you may get that sense from this talk that actually privacy is actually quite a technically complex area. It's actually quite hard to grasp, especially if you don't interact with it daily in your work. So one key consideration about that was, how do we design a user interface, that allows users to quickly grasp these concepts quickly without necessarily having to digest all these, technical complex algorithms and all that. So that's part of the thinking behind designing Encrypt. Yeah. I see a question over there. Great question. I think today a lot of data is inaccessible. I'm just starting from within even the public sector context for a start. A lot of data, you may see government from the outside as a big monolithic entity. You think we share data very freely, but oftentimes that's not the case. A lot of the times there are agency silos. Even between different divisions, people don't really want to share data. There are, not just the Statistics Act. Every agency has multiple acts with complex legal clauses that sometimes prevent them sharing data. And so we're looking to privacy technology as kind of a way to mitigate these concerns. And so the long-term vision, of course, is that data is shared freely without users' privacy being compromised, not just within the public sector, but also with the private sector. In short, we want to unlock the potential of data through leveraging technology. I hope that answers your question.
Earlier, right? The data engineering for our handbook. Will it be something, because from my experience, all the data engineering work or data replication, etc., is one of the main causes of harm to privacy to the data subjects out there. So will it be made available to public use, similar to open sourcing?
I think we have some colleagues from the data engineering DCAT team here, or
So will DCAT be made available publicly in a sense so that everyone can benefit from it? Because from our experience, or some of the privacy principles like data minimization, right? It is not really practiced by the data engineering teams or data analyst teams right now. And if we have a guideline for the data teams to follow, I mean, that is something that will be beneficial for commercials as well as the public side.
Yeah, so initially the DCAT, the data engineering playbook itself, it is for WOG at the moment. So what we are doing right now is we are slowly sanitizing it to make it available to the public. So in the near future, it will be available. Yeah.
Thanks. Yeah, one last question. So on the area of differentiable privacy, and maybe this is a little bit broad of a question, so maybe since doesn't apply directly to whole of government. So academic researchers may see a survey result or a published piece where differentiable privacy has been used. And you don't reveal the epsilon value just because you want to, or you may or may not reveal the epsilon value. That researcher or academic may want to then perform some test of significance, right, a KS test or what have you, to compare two different distributions. But they may not, but yeah, what is the expected way they're supposed to, what is the expected, how was the recommendation to go about that, given that differentiable privacy has been applied to those distributions, and that could affect their findings? Yeah, so in other words, how does differential privacy work when publishing results, but knowing that those results could be further analyzed by public or academics?
So you mean to say Is the question more about how do we go about setting the epsilon value like that?
Not even that. Just is it common practice to publish the epsilon value, or to at least
Yeah.
for the academics and researchers to then come to the original party and say, hey, I
Yeah.
would like to
Yeah.
analyze this data
Yeah.
with you, but I know you applied differentiable privacy,
Yeah.
so therefore
Yeah.
that might change results.
Yeah. So let me just add on to this thing. Right now, the current trend is that differential privacy has been used by large organizations, and they have released what epsilon value they have used. Most of them, most of the use cases. In fact, there is an article which has listed out all the publicly uh, listed epsilon values that these organizations have used. And I also listed down few of those. In fact, there is this research area which is looking forward to create a epsilon repository. With even this is from the author of the differential privacy herself, where she stated that, okay, whatever epsilon value you're using, let's put it somewhere in one place where other practitioners can also learn as to what is the right way to set the epsilon value. Because in general, there is no consensus as to what is the right epsilon value. So best way is to learn from each other. Okay, so yeah, that is the way. But yes, in order to simplify it for the small organization, or to help other practitioners to also apply differential privacy, one way is to develop the tools or interface as I just mentioned, and provide a convenient interface as to they can see, okay, if I'm applying a specific epsilon value, how is it impacting my accuracy? Some kind of visualization. Okay, and even it's also important whether differential privacy is the right use case for them or not. One way is maybe they can just test the data quality and see whether how much data loss they can, so data utility loss will get on using differential privacy. So yes, there are different research areas that are ongoing, how to make differential privacy convenient for the users to apply with ease. Yeah. Did that answer your question?
Yeah, mostly.
Okay.
Thank you. Quick technical question about encrypt. So when user upload his data set, let's say CSV file, do you store it and how long?
Hello, hello. All right. Yeah, so at this point, definitely we store the data, but the data is in transient, right? So the moment, say, you saw that we have, the first step is to upload the data, and then we keep the data for a certain period of time where the users have time to actually transform the data, anonymize the data to a certain standard. And usually, after they are done actually applying the transformation, then we delete the data except for the anonymized data so that they can still download the data for a temporary amount of time. However, you can also imagine the situation where you upload the data and then they just leave the step, maybe in the middle, right? So that's where we keep to a certain amount of time, which is, I think, at this point is about 8 hours. And from there, we will just remove the data thereof. So that there's no data that we store for a long period of time, just for our use cases. Yeah.
Thank you. I think that there is a question from the back. I saw a hand just now.
Hi. I have a question about Snowflake. Just now, the team has shared about data clean room. Is there any example of use of data clean room in public sector and healthcare sector currently?
Hello. Yeah.
Thank you.
Yeah, when you ask me about public sector, I'm not sure whether I should be looking at myself or or the rest of the room. As far as I'm aware, I'm not aware of any at this moment in Singapore. Yeah. Yeah. We've seen a lot of data clean room examples, mostly around edtech and commercial entities. So two commercial entities collaborating together. So I think in Singapore, you start to see collaborations when two organizations are forming some of the new or DG banks. So a telco and transport mobility operator. I'm not trying to give anything out. Or a bank and a supermarket chain. So these are some, I mean, I'm not saying they are our customers, but these are organization that comes together to form digibanks. And as part of that, they see data clean room as a form of an avenue to share data in the right way, in a secure manner. Yeah. Yeah. But some of the examples that I shared are mostly in the overseas. Yeah.
Hi. Question for Jia Hong. So actually, how would the cost sharing look like for the two-party model like that, especially if you are like across two different public clouds, like one will be on Google, one will be Azure, you'll be incurring a vast amount of cost as you ingress the system, right?
Yeah, so I think there's a comment around the egress is a tax on the internet. So, so there's no way around that in that sense. So I think our philosophy is to help elevate or simplify the pain so that we simplify the movement of data. So the tax will still be there. So it's just whether we are controlling the freshness of data against the egress cost. Yeah. So we believe in co-locating the data to where the consumers are. Yeah, so we are assuming they are both on Snowflake. Yeah. You're asking from a technical point of view, or from a legal point of view? Costing point of view. Of course, party one would like to monetize their data. And for party two, they would like to buy advertising slots, for example. So they would actually work out, some form of collaboration. So either I'm finding a better way to drive my marketing campaign in a much cost-effective manner. So for party one, I'm giving you this benefit that if by combining with my data, you would have a better targeted marketing campaign that you can run. So in that sense, the charging model could be, we collaborate together, but I'm charging you for advertising slots. But those advertising slots could be, be prorated or something that they agreed upon. Yeah, so our technology is just to facilitate that whole data collaboration.
So thank you for everyone's questions. I think you can catch up with the speakers as you mingle around later. So thank you once again to all our speakers today who answered the Q&A and did this great sharing throughout the evening. So thank you very much. And as our speakers make their exit, we will be actually wanting to hear from you guys. So your feedback is really important to us so that we can improve the next data science and AI session for you. So if you could just scan the QR code here, we'll be very, very appreciative. Also, thanks very much to Data Science SG today for being our partner. I would like to call out for their upcoming two meetups, which is on the 18th of May and the 20th of June. So if you guys are interested, please go to the Data Science SG meetup page to get more information. And also keep a lookout via our Telegram group chat as well, where we will let you guys know about our next session, which is on cybersecurity. So if anyone's interested on that topic, please feel free to join us, same place and same time. So thank you everyone again. Oh, sorry. And also, sorry. I know you guys are eager to speak to our speakers, but one last call out for anyone who's really interested in data science and AI job opportunities here in GovTech. So once again, please wave to the lovely ladies on the side, Felicia and Huijia. Thank you.
Hi guys, sorry. While filling up the forms and all this, just a quick check. How many of you know about this meetup through Data Science Singapore? Okay, how many of you know Data Science Singapore through StatX meetup? Okay, I need to charge for this already. Yeah, so anyway, just kidding. Okay, thanks very much for coming. So just a quick repeat. May 11 for StackX meetup. Then after that, we have one on the 18th and one on June 20th for Data Science Singapore. Okay, so look forward to seeing you all again. Thank you.